All right, beautiful. Okay, let's talk about multiplication. We'll jump into division here in a little bit, but I want to talk about some things that we may have forgotten in multiplication. So, how are we with our multiplication tables? Give me like a thumbs up if you're like, yeah, I'm really good, or like, yeah, or yeah.
I'm like, yeah.
Only thing I can suggest is like a phone on your app. I'm sorry, an app on your phone. Phone on your app. An app on your phone that when you're waiting for the bus, you're sitting before class, you can just go through, because having those multiplication, knowing those numbers in your head is going to help you with everything. It's just not easy to do on your fingers. It's the memorization piece that we need. So when we have a multiplication problem, there's ways that we can tell you that we're multiplying. So the first one that we're used to is that little X in the middle. The one that we're going to commonly see now is a big dot in the middle. Okay? That means multiplication. If we see a number written next to a letter, that means multiplication. And if we see 2 or 3 letters written next to each other, those all mean multiplication. So this is 3 times n, this is m times n times x. So I just want to kind of familiarize us with those. Also, if there is parentheses in a number, that means multiplication. Okay, so all of these ways we will see throughout the quarter, and that tells us that we are having to multiply 2 numbers or 3 numbers together. So file those away. Okay. When we have a multiplication problem, we have 2 numbers, call those factors, and they make an answer, which is called a product. Okay, so 2 numbers or 3 numbers that multiply to make up a number, we have factors, and they make a number that's called a product. So let's just say I have the number 12. Can you tell me what numbers, what factors multiply to make the number 12?
6 and 2.
6 and 2, good. So 2 times 6, so we have those 2 factors. What other things? 1, close, 1 and 12, good. And then 3 and
4.
3 times 4, good. So all of these are factors of the number 12. So how many factors does 12 have? 6. Yeah. So factors are numbers that make up a multiplication problem, okay? And then the answer to a multiplication problem is the product. So those are important vocabulary words to know. We'll deal with factors a lot when we talk about fractions. So it's good to kind of grasp that concept now. Okay, we okay with that? Multiplication sign, that dot. When we have a number written next to parentheses, it means multiplication. And then factors are numbers that multiply to make up a particular number. Okay. Can I erase what I have here? Good. We have some rules in math that are they're law. They always happen. So I'm going to say the rule of 0. Say it.
0 is 0.
Yeah.
So like if it's 0 times 2, it's 0.
Perfect. Any number multiplied by 0 will equal 0.
So I got a question.
Yeah.
So I've seen people do it. They write the 0 and then put a line through it. Is that a
Yeah.
0? So that is a 0.
That is a 0. It's, I think, the European way, sort of like the 7. Some people write 7th the line through it. I think that's a European, an Arabic style of writing. Either ones are totally fine for me. Okay, so the rule of multiplication says, the rule of 0 for multiplication says, I can take any number, I can multiply by 0, and I can get 0. The same thing with letter. I can take any letter times 0 and get 0. Okay, so anything. If I multiply Shaylin by 0, I'm going to get 0. Okay? So that's the rule of 0. Here's another rule, and I don't care so much that you know the name. It's called the associative property. Properties in math are rules, they're laws. So the property of 0, the multiplicative identity. Okay, so the associative property tells me that I can flip numbers around and still get the same answer.
Is that a U?
No, this is a C and an I. My handwriting is so bad. Associative, and then this is property. So basically this one says I can flip numbers around in order. Okay, so for example, if I have 2 times 3, what's my answer going to be?
6.
Good. If I flip these two and multiply 3 times 2, my answer is still going to be 6. Okay? This is the same rule that you can do in addition as well. I can take 2 plus 5 and get 7, or I can take 5 plus 2 and get 7. So it's just good to know that I can flip numbers around in multiplication, it doesn't change the answer. I can't do that for subtraction, I can't do that for division. Okay, good. Okay, we feeling okay with those 2 rules? Got some? Okay. Feel good? Yes. You're like, yeah, so easy. Okay, let's talk about a couple tips and tricks. Okay, let's talk about multiplying by tens, hundreds, thousands. Love them. So if we're going to multiply by tens, hundreds, thousands, anything that ends in 0, okay? All we're going to do is take the original number and then add the amount of zeros we need. So for instance, if I have 3 times 10, I'm going to take the original number, 3, and I'm going to add the amount of zeros I'm multiplying by to my answer. So 3 times 10 is 30. I took the original number and I just added on 1 0 to the original number and I got 30. Let's say this was 34 times 10. I take the original number, 34, and I'm going to add how many zeros to the back? 1. So I don't have to do any sort of math manipulation when I'm multiplying by tens, hundreds, or thousands, because I know I'm going to take the original number and I'm going to add however many zeros I need to the back. What if I was multiplying 3 times 100? Take the original number. How many zeros am I adding to the back?
2.
2. Perfect. Okay? 34 times 100. Take the original number and add 2 zeros to the back. So I want to kind of review that with all of you so that when you have, anytime in your math life, you have multiplying by 10, hundreds, or thousands, you don't spend time actually doing the math by hand. You go, I take the original number, I just add how many zeros I need, there's my answer. So that will save you time and will help, especially on tests when you're like stressed out. You just go, right? Take the original number, multiply. Okay, so that's a tip and a trick. So then let's talk about the actual multiplication. And let's talk about how we set it up. So whenever we set up multiplication, we put the number that's the largest on top, always. And remember, that's the associative property where we can flip anything around. So the larger number always goes on top. The second number starts from the right and then fills in from the left. Okay? Now how we do this is you take the first number and multiply it by the first right number. So yes.
So what I got taught in, I think, middle school, so sevens, like it kinda got taught, so 1, 2, 3, 4, so you go like that, 10, 11, 12, 13, 14, 15, 16. Would that work as much or no? Or I'm doing it
I
wrong?
think you're doing it wrong. There is a sevens rule. I'll look it up. There's something you can do with your fingers.
Yes.
I can't remember what it is, but if someone else knows, let me know. So 7 times 4, and anyone know that off the top of their head what 7 times 4 is?
20.
No.
28. Good. So we're gonna put the first number down in the ones column, right? So we have 28. We talked about yesterday 28. So this would be the ones column. This would be the tens column. So we're gonna put the 8 in the ones column, and then we're gonna carry the leftover 2. So we're making the number 28, we're just spreading it out. So the 8 comes straight down, and it's really important in multiplication that you keep your straight lines. Because when things start getting skewed, get problems. Okay, so the first number we took was 7 times 4. We put down the ones column, which was the 8, we carried the 2. Now we take 7 times 3. So then we move over to the left. So we're going right to left, which is hard for us because we read the opposite way. So 7 times 3
21.
plus 2. So we're going to add this extra piece on there. So 21 plus 2 is
23.
23.
Yeah, I did that wrong.
It's all right. That's why we're doing this.
I multiplied it by 5. That is actually 3.
No worries. So 34 times 7 equals 238. Good. Let's try another example. So 74 times 3. So remember, I'm going to take the first number straight above. So 3 times 4.
12.
Good. So what number goes down and what number gets carried? If 3 times 4 is 12, how do I write that?
Put the 1 above the 7.
Okay?
Put the 2 under the 4 and 3.
Perfect. Okay? So then what's my next step?
Then times 3 times 7.
Good. Which is, Dominic, you're on.
21.
21.
Alright.
And then-
Plus 1, which is 22.
22. So Dominic's our human calculator. We're going to use him for
I
everything.
can't do that in my head.
I will print off some multiplication charts that we can use when we're doing this, but just promise me that you're going to download some app. You're going to tell me this is a great app. You're going to use it. And so
Calculator.
Okay. Calculators? Okay. I love calculators. We carry them around in our pockets. But there are some instructors who believe that we need to do this without calculators.
Yeah.
I am not one of them, but I have to prepare you for the next instructor. Okay. So, let's talk about multiplying double digits. Isn't there a song? Double digits. Okay. So, moving on. You guys grasp that. Let's talk about double digits. Let's do 37 times 21. We put the larger number on top, no problem. We're going to start in the ones column, so 1 times 7, Spencer?
7.
Perfect. Put that down below. Then my next step is going to be what?
1 times 3.
Perfect. What am I going to get?
3.
3. Okay, so I have used this 1. So therefore, I have to hold the place value below this. Because I'm going to do the first row right here. So I multiplied those two as my first row. Now I'm going to move to the second row, but I cannot use this column. It's done. The ones column is done. So put a 0 there to hold that place. Some people put an X. I put a 0 because I'm keeping numbers with numbers. So once I bring that 0 down, now I can start with the 2. So I'm doing the same thing, going right to left. I take the 2 times the 7.
14.
Yep. Put the 4 down. Carry the 1. Good. 2 times 3.
6, 7.
Plus 1 is 7. Fantastic. So here is why we have to keep those numbers in columns. And perfectly in columns. Because my first row was 37. My second row was 740. Now we're going to add those 2 rows together. So 7 plus 0.
7.
4 plus 3,
7.
7 plus 0, 7. So my final answer is 777. It's all about keeping those rows. Spencer, how you feeling? Okay. It's like, we don't do this all the time, so we're like, oh, gotta go back to it. Let's do another example. So let's do 3 rows this time. 204 times 136. Okay, 204 times 136. All right. Shaylin, start us off. What do we start with?
4 times 6.
4 times 6. Dominique? 6 times 4. 24. 24. Okay, so what goes where?
4 under the 4 and the 6.
Okay.
And carry the 2. And it isn't that 6 minus 0 is 0 plus 2 is 2.
Good. So 6 times 0 is 0, but we have to add 2, so that 2 comes straight down.
And then isn't it 6 times 2, which is 12?
Yes, so we went 6 times 4 first, then 6 times 0, now 6 times 2, which is 12. And because that's the final number on the top row, we just write the whole number that's down. So remember we were carrying over our numbers, but now we hit the last number, so we just write it down. So row 1 is done. So what do we have to do now since row 1 is done? Put a 0
the 4.
below column, below the 1's column. We're done with it. Okay, so I'm gonna erase my little arrows here because then they get super chaotic.
And then isn't it 3 times 4?
It sure is. So now we take this, the tens column, or multiplying it right to left. So 3 times 4 is 12. So I put my 2 down, carry my 1, and this is where it can get confusing because I've got a bunch of other numbers there. So you can cross them out. I just erased it because I have a dry erase board, but I usually cross it out and put it above it. So 3 times 0.
3 times 0 is 0 plus 1 is 1.
Good. Okay. And now 3 times 2,
6.
6. Okay,
And then
so
add.
hang on. So this row is done. Sorry, this number's done. The tens number is done. So now we have the hundreds column. So what goes here?
0.
Because I can't use this column anymore. What goes here?
0.
Say with conviction, 0. Can't use it anymore.
And
So now I have the hundreds column, which I was nice to you and gave you a 1. So 1 times 4,
4.
1 times 0,
0.
and 1 times 2.
2.
Good. Now we add all those up. So I think what gets my students confused is that we end up shifting so far to the right because we have these zeros. So we kind of be like, ooh, it doesn't feel right because now we're shifting over. The first row is pretty easy. Most of my students are like, oh, I love the first row because it lines up perfectly with what I need to do. Second row then kind of gets off kilter. The third row really shifts over so I can see where that screws people up. And then we start writing sideways and we can't read if that's a 2 or a 7 or a 0 and a 6. So take your time. 4 plus 0,
4.
2 plus 2, 4, 5, 6, 7.
So
That's what I got. Okay.
7 for your next one and 2.
And 2. Good. Woo! And this is just going to take practice. And I'm okay with you working it out and then checking on your calculator. That's cool. But just using my calculator does not help you develop these skills. So I didn't give you too many homework problems. You'll have plenty of time to do it. Any questions? Anything that I forgot to add that you've heard before? Or any way that you do it that's differently? Feeling okay? Alright, let's talk about division. Everybody's favorite.
No. Well, some, yeah.
Yeah. Alright, let's talk about the law of division. So there are different ways to write division. You can write it with this division sign. It's that line and 2 dots above it, one above, 1 dot below. We can write it with a division bar or a division box, which looks like that. We can also write it as a fraction with a division bar. So we're used to seeing fractions, and we think of them as something totally different. Fractions are just division problems. That's all they are. So if we tackle division early and we feel confident about it, we're going to have an easier time with fractions. So if I'm saying this out loud, what I'm actually saying is 6 divided by 3. 6 divided by 3. This is said the same way. And what makes this confusing is this one reads left to right like we normally read. How we say this one is right to left. 6 divided by 3. So this is the same thing. 6 divided by 3. That's how we say that. I can look at this and also say 3 into 6. But we cannot say 3 divided by 6 because it's not the same thing. This is the same way. 6 divided by 3 or 6 over 3 is how some people say it. But get in the habit, especially on this one, I'm going to start it, about saying the number that's inside the division box first. This is 10 divided by 5. This is 8 divided by 2. Okay? Alright. There's a law in division. The law says that whatever numbers are on the outside of the division box, they must multiply to make the number inside the division box. Always. Always, always. These two numbers must multiply to give you this number. Otherwise, it's not a math problem. You've done something wrong. And you can check that. What's 10 divided by 2? 5 times 2, 10?
10.
Yeah. 7 divided by 1 is 7 times 1, 7?
Yes.
Yes? Feeling good? Okay. So now I'm going to blow your mind. I'm going to give you 2 examples. The first one is 10 divided by 0. If I put an answer up here, if I put 0 up here, or I put 10 up here, can I multiply any number? Can I put any number up here that will multiply by 0 to give me an answer of 10?
No.
No. Right? If I put 0 up here, 0 times 0?
0.
0. If I put 10 up here, 10 times 0?
0.
0. So this problem you can never ever do. You cannot divide by 0. This is called undefined. It means the math god will not allow it. Can't do it. Okay? Undefined. So you can never have a 0 outside the division box and finish that problem out. And sometimes in our homework they'll sneak some in there and they'll say, hey, can you do this problem? And I want you to be like, nope, undefined. But you can have 0 inside the division box. Because I can take 0, multiply by 10, and get 0. So 0 divided by 10 is 0. 0 divided by 5, 0. 17 divided by 0, I'm sorry, what is 17 divided by 0? The tricky one.
You
Can't. Undefined. You can only have 0 inside the division box. Okay. Let us practice our division. And I'm gonna start with some easy ones. So 36 divided by 2. When we are dividing, it's simply the opposite of multiplication. Because I told you that when you have these two numbers, they have to multiply to give this inside number. So we're gonna do the exact same thing when we're dividing. So the first thing that I'm gonna ask myself is, can 2 evenly multiply by something? Can I multiply 2 by something that will give me a number close to 3 without going over? Okay, so I can look at my math tables. 2 times 0 is 0. 2 times 1 is 2. 2 times 3 is 6. So can I multiply the number 2 times something that will give me close to 3 without going over it? Because this is too big, right? So I can take 2 times 1 and get the number 2. That's pretty close to 3. As close as I can possibly get. So I can take this number, and I'm going to put it right above the 3. Because remember I told you that these two must multiply to give you the number inside. So 1 times 2 gives me, what's my answer when I multiply 1 times 2? 2. That answer goes right below the number. Right below that first number. Okay? So I'm just doing the opposite. I multiplied 1 times 2 is 2. I'm going to now subtract. So 3 take away 2 is 1. Now I bring the next number down, and I always draw little arrows. I like them. They're fun. And I want to know what numbers I've used. So now I bring this next number down. And I'm going to do the exact same thing. 2 times what number gets me close to 16 without going over?
8.
And I can do my multiplication. 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. 2 times 7 is 14. 2 times 8 is 16. So this is my magic number, 8. So I put it right above the 6. That's the number I brought down. Eight times 2 is 16. I subtract and get 0. So a division problem is done when we have 0 as our answer, when we have a remainder left over, or when we are told we're going to round to a certain number. But we're going to keep practicing our division until we end up with a 0 here. That's our goal. Okay? So then I can check my work. I can say, hey, if I take the number 18, and I multiply by 2, will that give me 36? Sure does. So division is just the opposite of multiplication. Let's try some more. Okay, let's take 906 and divide by 3. So the first thing I want to look at is that number 9. I'm going to start with the very first closest number. Can 3 multiply by a number and get 9, or get really close to 9? Let's do our multiplication table. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. So we see that 3 times 3 is 9. So that means I can put the 3 directly above the 9. Okay, my 3 goes directly above the 9, because 3 times 3 is 9. I subtract, what do I get?
0.
0. So I bring down the very next number, which is 0. So now I have to multiply 3 by something and get 0. So 3 times
0.
0. Fantastic. I subtract. I bring down the next number, which is 6. 3 times what number will give me 6? 3 times 2. So 3 times 2 is 6. I subtract, I get 0. There's no other numbers to bring down. I have completed my division problem. 302 times 3 equals 906. Life is fabulous. Let's do one with the remainder. $15 divided by 4. How many times can 4 go into 15 without going over that number? Let's do our math. Four times 3 equals 12. 4 times 4 equals 16. So that's too big. So 3 times. Now here's the kicker. I can't take 4 and multiply by something and get 1. I can't do it. I have to look at the whole number 15. So that means I put my answer above the 5. Why didn't I put my answer above the 1? Can you think of a reason why I didn't put my answer above the 1? Just give me a guess. What do you think? Spencer, what do you think? Just go for it.
I got nothing.
Just try. Just give me something. Just,
Why you didn't put it above
yeah.
the 1?
Why didn't I put it above the 1?
Because it was too high.
Yes. Cute. See, look at you. I can't go into 1. 4 cannot multiply by anything to give me 1. I can multiply by 0. So I can put a 0 there. 4 times 0 is 0. I subtract. I bring down the 15. So it's ultimately nothing goes there because it's too big. So then I do 4 times 3. And what do I get for an answer?
12.
12. Okay, so I put that right below the 15 and I subtract. 15 take away 12 leaves me with what?
3.
3. Okay, so here I am done with my problem. I don't have any more to go, but I have this left over, this remainder piece. So we were told, hey, long ago, just put a little r and you have 3 remaining. Okay, sounds good. So, remember I told you that when you have to multiply everything up here, it must equal 15? Here's how it works. 4 times 3 is 12. 12 plus 3, adding the remainder on, is 15. So the law it holds up, it all works out. When we get into decimals and fractions, we will actually keep bringing zeros down and buying more decimals sort of thing. So we'll actually finish these problems out, but for right now, we're just gonna stick with the remainder piece. Let's do one more example, and let's do it with a double digit. Double digits are terrible to us. And this is where it's gonna be really painful for us because we're getting in numbers that we don't know what they multiply. Like, I don't know my 12s very well. I know 10s fabulously. 11's pretty good because I just repeat the number, but 12, like, yeah. Okay, so Spencer, you told me that I couldn't put a number above that 1 because it was too big. Is the 4 the same thing? Is 12 too big to put a number above 4?
Yeah.
Good. So I'm gonna have to put a number above 43. Alright, so I gotta figure out 12 times something is gonna get me close to 43 without going over. So off to my right, I'm just gonna do my multiplication. 12 times 0 is 12. 12 times 0. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. Okay, so I can stop right there. Then here's my little cheat sheet off to the right. I know that I have to get close to 43, but I can't go over. So which number am I going to use to multiply that 12 by? What number gets me the closest to 43 without going over? What was that?
36.
Yeah. So I want to get to 36, but what number am I multiplying 12 by?
3.
3. So where am I going to put that 3? Am I going to put it over the 4?
No.
I'm going to put it over the 3. Good. And I've already done my math, so I know that 12 times 3 is
36.
36.
perfect. So that 36 goes right below the 43. I subtract. Now I know I can't take 6 away from 3. I'm going to have to borrow. Because 6 is too big, so I'm borrowing one number, which makes it 13. So 13 subtract 6.
7.
Good. Okay, now what do I do?
Put a 0 down because you can't do 3 minus 3, which is, well, you can, but it's 0.
3 minus 3. So remember we subtracted, we got our answer. Now we bring the next number down. Yep, good. So we bring the next number down, which is the 6. So now I have to figure out 12 times some number that's going to get me close to 76.
6.
Is it 6?
I believe so.
Okay, so let's
72.
12 times 6 is 72. And we could have done 12 times 5 and got our answer, 12 times 6 and got our answer, but Dominique was awesome for us. Okay, so what number goes above the 6 here?
6.
Yep. And what do I do with the 72?
Minus 76.
So I put the 72 right below the 76 because 6 times 12 is 72. I subtract.
6 times 2, times 2. Wow. Minus 2, and that's remainder.
And that's your
36, remainder of 4.
Good. 36 remainder 4 because I have no more numbers left. And that's what's left over. So when you have double digits over here, there really isn't an easy way other than thinking about, oh, I can start with 0 and go all the way through, or I can say, I think I'm going to start with 5. That number's too big or too small, and I can shift from there. But it's keeping your scratch work off to the side so that you can go back to it and see what numbers you need. And remember, it's just the opposite of division or multiplication. So 36 times 12 plus 4. And it's just going to take time. We're just going to do this. I'm here to help you with your assignment today.
What one do I click on?
So let me show you. Let me freeze this.